I am a data science consultant, especially doing NLP these days, along with a bunch of other data science-y problems. I also used to do data visualization, and in fact co-ran a conference called OpenVisConf a few years ago, which was, I will say, less well organized than this. So kudos to you guys. I have also been a professor at various points, but talk about a difficult job. And these days I do a lot with creative AI, which my newsletter reflects as well. So I work part-time with Google Arts and Culture and other clients. And I'm going to talk a little bit about some of them today because I've had some interesting problems with them. I've got a lot in this deck, and I'm probably going to go kind of fast. I'm not going to spend a ton of time on the code examples, but having been a professor, I believe solidly in giving code examples, and I spend a lot of my days looking for them online. So there's going to be a bunch of code, including stuff I'm not going to cover in my repo that will be linked from these slides. So you can find how to do things from that. And this is the essential plan. The last one, MISC Life Tips, is some of the tools I used that helped me solve some of the problems I'm going to show today. And we may not get to it. We'll see. So I'm going to use today a bunch of data related to text to image. So unless you're living under a rock, you know about these models where you can type in a phrase of what you want to see, and then you get an image out at the end. Stable Diffusion is the most popular open source model. And there are a bunch of repos of prompts that people have typed in, including this one, which is Lexica. So I'm going to use a sample of these for some of my examples today, just so you know what's coming. The first technique I want to talk about is called UMAP, which is a data visualization technique. This is incredibly useful for exploratory analysis. I've been using this technique of dimensionality reduction for a while, and before it was UMAP, it was TSNE, which people call TSNE, which drives me nuts for some reason. But anyway, we've got UMAP now, which is a little bit better, although related, as papers have shown. And it's something that allows you to get a glimpse of your data, a big picture text data, and really impresses clients, just as a side note. This is an old, not very pretty or sexy picture that I made using TSNE. This is a word-to-vec embedding of a bunch of poetry on Gutenberg books, so open source poetry. Alison Parrish collected all of this and turned it into a corpus that people use for various creative text projects. I was using it for a talk a few years ago, and then later was using the same corpus for a text generation project. And the first thing I did was this TSNE display of that poetry colored by date. So this is words, not sentences, embedded using word2vec. And then I mean, it's a blob. It's not like a good separation of anything, but the coloring and the sort of shape of it helped me discover something that I had suspected when I was playing with the data in a generation algorithm. In particular, this blob on the lower left is like archaic Latin, old English types of things, which basically were screwing up a lot of my output in this project. And having made this picture and done this color coding, I was able to clean the data set to turn it into something a little bit more modern, which is what I actually needed. So this was a tremendously useful display for me at the time. I do this all the time still. Now, frequently it's with sentences, or in this case, prompts. So this is prompts in this online data set that I'm going to be talking about, where basically, in this case, I was looking at like a subset with, I think the word body was the subset that I picked for reasons that will become clear. And I did this interactive display so that I could take a look at like, how was the word body appearing in these prompts? And in particular, like, is it a bad use? Because I was interested in not safe for work content detection. Making these interactive things, like the little GIF I just showed, is actually incredibly easy these days. The tools are just getting better and better. It's very easy with sentence transformers to just pick whatever model you want. Body prompts in this code example is just all of the text strings that have the word body in them. We do our model encoding, then we run it through UMAP, which is this dimensionality reduction algorithm that Leland McInnes published. And that gets us XY coordinates, a two-dimensional matrix, which we can then turn into an interactive plot. Doing the interactive plot code is actually surprisingly easy. I mean, I'll put this in my repo, but basically we're going to use this library called Bokeh. And the thing that's cool about this library in particular is that you can either output in your notebook, in your Jupyter notebook, or you can make a file. And the file is self-contained, so you can send it to a client or show it later or save it in your repo. And it's fully interactive, where you can mouse over the text and see what the text is. So you can put HTML on the tooltips if you want. So that's that little hand symbol that you see there. That's me putting some HTML in. So it's really, really easy. This is another couple of examples. This is a different data set where I was looking at the use of the word blood in these prompts because I was concerned about whether blood was being used in like a really gory way or whether it was just sort of generic. And it turned out actually that very few of them were really gory. A lot of it was very generic. So in particular, down at the very bottom is a lot of references here to blood moon, which is just a phrase, right? It's not especially about blood. So one of the things I end up doing a lot with these plots is sort of a crappy labeling where I basically outline like what's happening where on the plot in terms of content. This is painful and involves, doing sort of XY coordinates, getting an average, and then or just doing it by hand. So this over here on the right is one where I took, this is a bunch of books, and I did various averaging over the books for genre purposes. And the authors are the color coding here. And then I went into Photoshop and I did a really, really careful labeling job with all the content. So that takes a long time. And I mean, hopefully the tools for doing this are going to get better and better. The libraries for doing this are getting better and better. It's super powerful when it's presented nicely. And the interactive side of it is very cool too. So you might have seen this thing from Gnomic AI, which is actually Ben Schmidt, who's a digital humanities guy, who's essentially a data viz genius. He did this thing with all of these prompts from Krea.ai's stable diffusion search engine. It's very cool. All right, so relatedly, our previous speaker, Vincent Warmerton, he's been working on a tool called Bulk that supports selecting from one of these in order to do labeling or to help with labeling in a kind of weak supervision method, which I had been doing before. So as soon as he released this library, I sent him like 6 issues of feature requests. And then Leland McInnes, the UMAP guy, is also working on a library called This Not That, which might actually end up being better for data viz artifact creation. I don't know. I haven't had time to dig into it, but it looks like it's really cool. So that's essentially one of my main tips is like, if you do these displays, which are not actually hard to make anymore, you can get a whole lot of mileage out of them. They're fun and people like them, and you can make them look really good. Okay, so leaving behind the fun and not hard to make, let's talk about like real entity recognition issues in the wild. I've had 2 client issues this past year that raised so many issues around the tooling and the decision making and the design of these problems in this problem space. So here's one of the client problems. Suppose you want to see trends in searches in these prompts. So you have prompts like you see here from Lexica, where people are visualizing content, like in this case, castles, and they're putting in names of artists that they're interested in using as sort of inspirations. We all know that this is like a vexed issue in terms of artist citation. So suppose you want to track like who's being used in these artist names. Well, that's an entity recognition problem, right? It's also kind of hard for various reasons. I mean, right out of the box, it looks like it ought to be easy, but here's why it gets hard. So I took 80,000 Stable Diffusion prompts, and the repo link is shown there. There's much bigger sets out there, but for the purpose of this talk, I didn't want to use a big set. Ran it through Spacy, natural language processing libraries, BERT-based named entity recognizer, and got these totals. So right away, you can see the ones in red are essentially the same artist. Artgerm, Stanley, Artgerm Lau, it would be probably in quotes there. So like this is one of those immediate questions that you hit immediately when you do one of these projects, which is, what do we do about that? I want to point out for people who know about using databases of entities to disambiguate or to link, a lot of these artists aren't in Wikipedia, that you have to go to other places to get any kind of like canonical reference ID or page for them. So yeah, the thing that comes up quickly with this kind of project is, what are you going to do with these? Like, what do you care about when you want to look for entities like that? So for instance, this is Mastodon's sparklines showing trending terms, hashtags on one of the servers. So in this case, like probably they don't care at Mastodon, but we might care from an NLP or data science perspective. Do we care that people don't know what the right term is? So for the Natural Language Conference, EMNLP, do we care that people are using both EMNLP 2022 and without the 2022? Should those be in some sense merged or not? So this is essentially an entity resolution problem. And the other question is like, do you want to know the truth about what people are typing, or do you want to know what do you want to know what they're actually typing in terms of how they type it out, the string, including mistakes, or how they refer to Artgerm? Do they know that it's Stanley Lau? And so all these questions come up quickly about like, what is truth and what are you going to be accurate with respect to in the data? You hit these problems immediately with this kind of project. So like I said, entity resolution is what we're talking about here, where we're usually talking about techniques that sort of identify, group, and link things to some object in the real world. So there is some artist who is Artgerm, and how do we talk about him, or how do people talk about him? And do we care about the differences in how they talk about him or not? So that's where the UI and the sort of system design part of it comes in. This is a huge topic of research and of tooling, and companies have solutions, et cetera. I'm a person, I'm not a company, but well, I am technically, but you know what I mean. So you end up doing research on like, what are the best ways to deal with this? You've only got a certain number of hours or days for the client or whatever. There's a bunch of papers and links that you can follow on this. But so some of the issues that you're going to come up with, you've done your named entity recognition, you've got in that data, you've got misspellings or orthographic variants that you found, like Leonardo da Vinci might be written in any number of ways. There might be misspellings like Leonor da Vinci. It looks like probably they're trying to refer to the same person, maybe not in some cases. And then we have things like name and label variants that are all true but are different. So this comes up a lot in researching things related to women's names. So Mrs. Smith, Mrs. John Smith, Pamela Smith, née Austin, like these are all potentially the same person. They're referred to, unfortunately, with a man's name in some cases. So your entity resolution situation has to handle these, right? Then there's misrecognitions of the model. So for instance, Mary's, it's actually Mary that's the entity, but this particular spacing model I was using often had an apostrophe S merged in with the token. Co-reference. So this is essentially another problem that sometimes clients care about and sometimes they don't. So Barry the Bat was a fun guy. Barry partied all night. Barry the Bat and Barry are referring to the same entity with different strings. So this is also classic with full names in journalism, and then you use the last name to refer to somebody. So sometimes clients want those merged and sometimes they don't. You need a co-reference detector to handle that, or crappy heuristics, which is what I end up doing a lot. All right, so tooling to handle this. So if you're just interested in counting and merging things, there's a whole bunch of tools out there that I've used a lot. One of them is the string grouper tool, which has various algorithms for how it tries to merge strings that might be the same. So it's a cool repo. I recommend looking at it. And you can do things like get what the similarity threshold is, use different algorithms, et cetera. But what essentially you're seeing here is I've run this thing over my list of artists or names from that data. And on the left is the original string, and on the right, it says right name. That's the first mention in the group that it made, that it's saying these are all probably the same thing. So you can see down at the bottom, Krenz Kuschart, et cetera, et cetera, et cetera. They're all basically the same. Now, you're going to find that you have errors in your data. So there's the apostrophe S's, et cetera. Some of them are just bad. You might want to use a different tool. So here we're looking at like a combined list of who are the biggest groups. So Greg Rutkowski, Alphonse Bucca had the biggest number of different variants, et cetera. Notice that not all of these are artists. Some of them are content of the image, like Emma Watson. So do you care is the question. Okay, so some of these things also have to be done by hand. So for instance, for big string differences, things like PricewaterhouseCoopers, PwC is a valid way of referring to it. So you have to actually create a dictionary that says this is a thing that also is this thing. So the by hand thing is super vexed. You have to do this a lot, it turns out. So James Jean and James Dean are not the same person. One is an actor and one is an artist, but string similarity would say that they should be duped, like that they should probably be grouped together, and you're going to have to manage that. So you end up doing a ton of by hand stuff and maintaining databases and sort of lists of entities. It's just a problem in this space that you have to do that. And the tooling around this isn't superb. I just end up in dictionaries and lists a lot. It's a big problem. I'm going to skip this and move on to the next example. So one of the tools that I use, actually, this is very normconf, is OpenRefine. So this is a GUI tool for helping you deal with data problems and sort of merge them and manage them. This is a great tool because I can just decide in this label, like right there in the list, how do I want to call that group and fix the string labeling issues. It requires a number of steps, and essentially what you want to do is you do this cluster and edit thing, and I recommend a sort of a workflow where you keep the original entity over in another column, and then you work off this column, and then you end up with a mapping so that you can use them later in a tool. All right, so wow, I'm definitely not going to get through all my slides. I knew this was coming. So basically, you'll be able to manage a dictionary of the original and the merged and export the data and deal with it. One of the reasons I want to talk about that is because dealing with rules is actually a big thing in NLP, at least in my world of NLP. You end up having to augment models with rules quite a lot. So Spacy has a bunch of tools for helping you deal with this, because you can write patterns and define rules that you can use as part of your pipeline in Spacy, which is super useful. So the entity ruler in particular allows you to say that this ArtGerm version is also this ArtGerm version with an ID. There's a whole bunch of docs and tooling around this that you can look at. So I'm now going to switch to this body prompts issue and the not safe for work classification problem that I was working on for one client. So say you have 8 million unlabeled examples and you're trying to work on a not safe for work porn classifier for these prompts. It turns out that one of the things that some of the moderators dealing with this data were looking at was mentions of porn stars. It turned out that that was actually not a bad idea. And in fact, in a lot of the cleaned up repos of this kind of data, the porn stars are still in there because nobody thought of ruling them out as content problems. So for instance, in this data set I was looking at. And let's talk about why that is. So the text itself is not bad, but the output image will probably be bad because it's been trained on photos of porn stars. So this is I was like, okay, this is an obvious gazetteer problem. I just need a list of porn stars. Where am I going to get a list of porn stars? Well, it turns out Wikipedia is excellent at this. And why might that be? Well, that's because an awful lot of editors of Wikipedia are white men. And so it's just a known fact that the entries on women porn stars are amazing. So this turns out to be a very good database for getting lists of porn stars. So Chris Alvin's talking later, so I'm gonna give him shit about this, but anyway. So what I did, and this is something that a tool like Spacey will allow you to do, is you basically take a classifier that doesn't necessarily know enough about, say, porn stars, and you add them in as rules because you have this ability to do rules, and then you basically can override the text classification in case it doesn't know about the porn star and say, this is actually bad stuff. So I've spent a bunch of time doing these creative modifications of pipelines in Spacey, and this is one of them. So I'm here to tell you how to do that. So basically, all you have to do is define your own component that says, if I have a label that's a porn person, I'm going to call that a positive classification for porn, regardless of what the model did. And this is the crucial thing. It's override the model and just don't allow it in this case. So you can get the code from my repo or from the slides, but basically we load in a trained text cat model, and then we define our rules for all the porn people, and we say override and use those rules for the porn person instead. And this is just tremendously useful. So for instance, I can have coffee with Mia Khalifa in the coffee shop and come out with these entities. One of them is a porn person, so the classification is definitely this is not safe for work. Whereas otherwise, if it's not a porn person, I get sort of ordinary entities, and I'm fine. I've learned a lot about doing really, really wacky things with Spacey pipelines, some of which would not be probably approved of by the Spacey explosion team, but basically here we are. There's a bunch of examples in my code in the repo. And I just want to wrap up. So Peter Baumgartner, who's also speaking later, has a great post about rules in NLP. And I mean, it's essentially the process you kind of want to go through is sort of this, which is you use rules to help yourself train a model, and then you review your errors, you fix and improve your model. This is fantastic, but also you might want to keep the rules around. So in this case, I mean, rules are fragile, and in this kind of context, you probably want to have like absolutely call it porn or call it not safe for work if this name comes up. You don't want to allow the model to be unsure. You just want to say this is blocked. There are a ton of Spacey resources. I have become an expert on digging through them. You definitely want to use my list if you aren't up to date with how to use Spacey and how to learn among their tools. There's a lot of information sort of floating around. There's a giant scary flowchart, which I'll show you a glimpse of in a second, but it's very, very useful. They have a customized labeling tool, and essentially they're like great people, and two of them are speaking here. So obviously they're excellent. This is only a part of the giant scary flowchart, but it is tremendously useful. named entity
Sorry to
models
jump in, Lynn. If we didn't get to any questions, we got a real quick one for you. Have you found that there are some sentence embedding models that work better out of the box for the purposes of UMAP?
So I just try a bunch because, like I said, it's an exploratory method for me. So I just try a few until I see if I can see clusters. But the problem is that with UMAP, you also have like a bunch of different things you can control in the settings. So you can end up iterating a lot until you get to the point that you like your picture.